I'm Anil Kumar. Welcome to my series on linear relations. In this video, we'll talk about direct and partial variation. It is important to note that linear relations can be divided into two categories. One is the direct variation, and the other one is the partial variation. Strictly speaking, when a graph goes through the origin, in that case, it is direct variation. So this graph, which is shown in green, represents direct variation. It will pass through origin. The other graph shown here, which is in orange, this one here, is partial variation. We will have a graph which does not pass through origin. So I hope that point is clear. So that is partial variation. If anything which is non-linear, so this is non-linear, correct? Let me use a different ink here. Then it's neither. So that is the background on direct variation and partial variation. So whenever we are talking about direct or partial variation, it has to be an equation of a line, or on the graph, it has to be a straight line. Now, before getting into the details, we'll also talk about what are the linear relations. A linear relation that can be represented between independent variable x and dependent variable y by a straight line. So, normally along the x-axis, we have independent variable, right? So, this is the x-axis, and the dependent variable y is on the y-axis. So the relation between them will be linear if you get a graph of a straight line as shown in the green and the orange lines in this particular diagram. You can also find whether the data represents a linear relation or not by finding the first difference, right? So we'll take up an example to review how do we find the first difference also. In general, equation of a straight line is given in slope-intercept form as y equals to mx plus b, where the slope m is change in y over change in x, y2 minus y1 divided by x2 minus x1. So that is kind of important to remember. With that in mind, now let's explore what is first difference. So first difference also gives you rate of change, which is the slope and or the gradient. So let us see how do we find the first difference. I have taken two cases here, and in one case we have non-linear case, the other one is a linear case. Let us see how from the first difference we can figure out whether the data provided is representing linear relation or not, right? So important thing here is that the first difference is constant. That means we are looking into linear relation. Else nonlinear. Perfect. You know that. Now let's see. Now in this case, we have taken two examples. You will find that the values of x are changing by 1. So in that case, you just find the difference between the consecutive y terms and you get the first difference. So the first one, 1 minus minus 3 is 4, 5 minus 1 is also 4, 8 minus 5 is 3, but 12 minus is 4. clearly you can see that we do get a number which is different, and therefore in this case first difference is not constant and therefore it is non-linear. Do you get the idea? So the data represented by the first table does not represent a linear relation, right? So you can write here non-linear. Now let's look into the second one. In the second one, the thing is that we have given the values which are not consecutive terms. So in this particular case, we need to find the rate of change. So slope, which is change in y over change in x, or y2 minus y1 over x2 minus x1, that has to be calculated for each and every consecutive set. So for the first one, let's write down here, we have used the value right there. Y2 minus y1 divided by x2 minus x1 gives you the rate of change. 11 minus 5 divided by 4 minus 2, which is 6 over 2, gives us 3. So we get the rate of change as 3 between the first 2 points, which are at 2, 5 and 4, 11. And now let's calculate between the second and the third point. When you do that, you get that also as 3. Since 14 minus 11 divided by 5 minus 4 is 3. And now let's do with the other given points. So there, 20 minus 14 divided by 7 minus 5 gives you 3. And then the last set of points, which is 29 minus 20 divided by 10 minus 7, also gives you 3. So in all the three cases, we get the constant first difference, right? So first difference is constant and therefore the relation is linear. And that's why we conclude this, that this relation is linear. Is that clear to you? In our examples, we are explicitly going to use this particular method if we have the values of x which are not consecutive. Okay, now let's look into direct and partial variation and some ways in which they are similar and in some ways they are different. You know how they are similar. So let's write down how are they similar. Similarities between direct and partial. Can you tell me? One similarity is both represent straight lines. So that is how they are similar, right? Now, let's look into their details. So I have two columns here, one for direct, the other one is for partial variation. Direct variation, a linear relation when dependent variable y varies directly with independent variable x. That is direct variation. That is to say, we are saying y is proportional to x. Do you see that? So they are directly related. So in this case, they becomes a direct variation. If x is 0, y will be 0. Now in the case of partial variation, a linear relation where the dependent variable y varies partially. Partially means that some part of it varies, some does not. You get the idea. That is what it means by varying partially. And we have an equation here which we'll discuss later. Right? So that is first definition itself. Now, a linear graph which goes through the origin will be direct. Equation will be y equals to mx since it varies directly. In the table, the value of y are same multiple of the values of x. Now, this is very important property. In a table, the values of y are same multiple of x. So if you multiply, that factor will be m. Okay, so it is the same multiple of x. When you look into partial variation, we have seen that the linear graph will not go through the origin. The equation will be y equals to mx plus b, and in the table, y are not the same multiple of x. So ratio of y over x is not constant. Well, let's look into some graphs we have a graph here. They represent direct variation as they go through the origin, straight lines. Now here we have partial variation since they have different y-intercepts than the origin. And this is neither since this is non-linear. Correct? Now remember that the relation should be linear to be direct or partial variation. Varies partially means that a part is fixed and another part varies directly. Correct? So we have a fixed part which is the b in it and the direct variable part which is mx. So that tells you that y equals to mx plus b, that is partial variation. Since there is a part which does not vary, which is a constant. But if b is equal to 0, then what do we get? Then we get y equals to mx, and this is direct variation. Perfect. So that is how they are related. Now let's take some equations and verify whether they belong to direct variation or not. The question here for you is example 1. Classify as direct variation, partial variation, or neither. You can actually pause the video, write down your answers. You may also write down the reasons. Well, the first one is y equals to 2x minus 4. Because of this minus 4, we can clearly say that this is partial variation. It does represent a straight line. Y equals to minus 2x also represents a straight line, but the y-intercept is 0. When x is 0, y is 0. There is a constant which relates y and x, so this is direct. In this case, what do you think it is? My answer is neither. Can you tell me why? Y equals to 4 represents a horizontal line which is not varying at all. Do you see this is y equals to 4? There is no variation. So this straight line does not qualify for direct or partial variation. Correct? Therefore, it is neither. You get that. Now, the next point is y equals to 3x squared. This is also neither since this is non-linear. Now we have 2 over 5x minus 4. You see it is partial. Since it has when x is 0, y is minus 4. The third equation here can be rewritten as 3y equals to minus 2x, right? Or we could write this as y equals to, let me write here, y equals to minus 2 over 3x. And therefore, I could write this as direct variation. Now, these are three examples where in real life situation we are using direct application. Distance is speed into time. This is a direct variation. Faster you drive your car, lesser time it takes. So, or you move more distance. So, distance d equals to 60 times t is a direct variation. Circumference is 2 pi r, c equals to 2 pi r, represents a direct variation. Higher the radius, more the circumference. If the radius is 0, circumference is 0. Now this a equals to 100 plus 25p. We'll take some examples like a banquet party. You can book a hall for $100 and then the person may charge you 25 per plate. Right? So this is example of partial variation. Well, in all these cases, what you notice is that a linear relation y equals to mx plus b represents direct relation if b is equal to 1. Otherwise, it is a partial variation. Correct? So, we have seen how from the equation you can figure out whether it is direct, partial, or neither. Now we are going to do the same exercise, but this time with the graph. Classify the direct variation, partial variation, or neither. Find the equation of the line and justify your answer. Linear relation you know is y equals to mx plus b, but it could be direct if b equals to 0. So in the first case, the line is going through the origin. Clearly, this is a direct variation. The line here is partial variation as the y-intercept is not the origin. Here it is going through the origin and therefore it's direct variation. This is non-linear, so it's neither. This line goes through a point which is y-intercept different from origin, so therefore this is partial variation. The last one here is direct variation. So the student's exercise is to find the equation, right? For each line. You can submit your answers, find the equation of each line in the form of y equals to mx plus b. Remember, for direct variation, as in the very first case, the line will be going through origin, and therefore you can select a point and find the slope. So you know rise over run. So we go up by 2 units and run is also 2 units, and therefore we can write this as y equals to 2 over 2, which is just x, right? 1x, right? In this particular case also, you can select points. So we have selected these points. Let's say these are the points which we have selected. You can find rise over run. You know this value is at half, and therefore you can write down the equation easily. So that is how you should be in a position to write the equations, right? Let's move forward and analyze the data. In this case, we are given table of values. We need to classify as direct variation, partial variation, or neither. We need to justify the answer by providing three reasons. Okay, let's look into these cases. The very first one is the table where x values are increasing by 1. We can first find the first difference. If the first difference is constant, it is linear. Then we will check for direct or partial variation. So you can see 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 5 is 3. That means it is linear, right? Now since it is linear, we'll check the value at 0. At 0, it is 2, not 0. And therefore, we can conclude this as partial. Is that clear to you? That is how you have to do part B and C. So you can actually pause the video at this stage and then answer your question. Perfect. So first part, very important, is to check whether the data represents a line or not. Perfect. Now here's our solution. So the first one I did for you, it is a partial variation. Since what did we find? We find that the first difference is constant and it is equals to 3 in each given case. And we also found that at 0, the value of y is 2, right? And therefore, we have an equation which is similar to y equals to 3x plus 2. 3 is the slope, right? So m is 3, the first difference in this case. Perfect. And the y-intercept b equals to 2. And therefore, we get our equation. Perfect. So it is a partial variation. Now let's look into part B. In the part B, if I find the difference, 3 minus 0 is 3, 5 minus 3 is 2. Since it is not constant, right? So it is non-linear. Non-linear means it is neither direct nor partial. So that is how we can easily conclude. Now, in the first example, we were also supposed to provide three reasons. You get the idea? It is your exercise. You should do which are the three reasons. So first reason here is that the first difference is constant and it is linear, right? So first is linear. Second is that it could be written in the form of y equals to mx plus b. And the third, when it can be written like this, you find the ratio 5 over 1 is not equal to 8 over 2. So what we see here is the ratio of y over x is not a constant. And that is the reason why it is partial variation. Now, looking into this, we get the second one. When it is nonlinear, we need not give you the three reasons. But when we are saying that the next one, let's analyze part C. The data is, for 2 it is 3, 4, 6, 6, 9, 8, 12. Now these values of x are not the same, and I mean not increasing by 1. And so for each case, we need to find the rate of change. So let's find the rate of change for the first one, which is 6 minus 3 over 4 minus 2. We get a value 1.5. And now let's find the rate of change between the second two consecutive terms. So in this case, 9 minus 6 divided by 6 minus 4. And that also gives us the same value. Let's write down. We have 9 minus 6 divided by 6 minus 4, and that is 3 over 2, which is 1.5. So that is also 1.5. Now, let's do the last case, which is 12 minus 9 divided by 8 minus 6. Now, 12 minus 9 is 3, and 8 minus 6 is 2, which is also 1.5, and therefore we can relate that for each the change is constant, and therefore it does represent a linear relation. Correct? So that is one reason. Second, let's find the ratio of y over x. So what is the ratio of y over x? 3 over 2 for the first one, 6 over 4 for the second one, and 9 over 6. Each gives us 1.5. That is the constant ratio. Do you see that? Since we can now write this as y equals to mx or y equals to 1.5x, it represents direct variation. So when there is a direct variation, you could straight away find the ratio of y over x. Now here is the example for you to do. So we have three more questions. Classify them as direct, partial, or neither. Justify your answer by providing three reasons. You can now pause the video, answer these questions, and look into my suggestions. These are slightly difficult since in B and C you find that the variations do not include 0, so you need to figure out what happens at 0. Perfect. Here is my solution to part A, which is 0, 1, 2, 3, 4. These are consecutive terms, so we can straight away find the difference. So first difference, 5 minus 3 is 2, and here it is 3. So similarly to one of our examples earlier, this is not a constant, and therefore the answer is neither. B. We have the values 6, 15, 12, 3, 18, 45. We see that this changes by 6, correct? They are changing by 6. On the other hand, y values are changing by 15, correct? So now we know that there is a constant rate of change. So it does represent a linear relation, correct? You can always find the slope and then also write down the conclusion as we did here. So change in y over change in x is 30 minus 15 divided by 12 minus 6, which is also equal to 45 minus 30 divided by 18 minus 12, and both are 2.5. So here in this case, m is 2.5. Now we need to find the equation. So what you could do here is you can go back by 6. So if you go back by 6, let's say minus 6, you reach a value 0. Here you can go back by 15, and then again you reach a value, which is what? If you go back by 15, you reach a value 15. So it is a direct variation, correct? You can also see that the ratio of 15 over 6, ratio of y over x, is same as 30 over 12, is same as 45 over 18, and that is also 2.5, same as the rate of change. And so you can write down your equation as y equals to 2.5x. This graph will also go through origin. It is an example of direct variation. Clear? Now here is the third example. We have the data points as 3, 7, 4, 9, 6, 13. You need to verify whether this represents a direct variation or not. So one step you could do is you can find the ratio 7 over 3, right? Is it equal to 9 over 4? This is what you could do. Well, they are not equal, and therefore it could be a partial variation, correct? But before concluding, you need to find the difference. Well, the x values 3, 4, and 6 do not increase by 1. So we need to find the change. So find the change between these two, which is 9 minus 7 over 4 minus 3. This value is 2. Similarly, you also find the change between 13 minus 9 over 6 over 4. That is also 2. And therefore, we know it is a linear relation. M equals to 2. Now you can write down your equation y equals to 2x plus 1 by writing the general form and then finding the value of b, right? Even otherwise, you know what is 2 times 3 equals to 6 plus 1 gives you 7. So likewise, you could reason it out and then also write down the equation. Perfect. You will see that this does not pass through origin. When x is 0, then the y value is 1. It actually goes through 0 and 1. Correct? Now here are 3 questions for you to practice. This is question number 1. I'd like you to pause the video, take a picture of this, solve, and then take up the next question. Here is question number 2. These are practice questions similar to what we had just done. And here is question number 3. In question number 3, it is slightly different. Classify as direct variation, partial variation, or neither. Justify your answer by providing table of values and or graph. I'd like you to also sketch the graph. The table is given to you. The equations are y equals to half x plus 2. Then we have y equals to minus x and y equals to 2x squared. Clearly from the data, this is partial, that one is direct, and this is neither. However, you have to calculate the values, fill this table up, right, and then sketch the graph. Clearly, this graph will be a straight line moving upwards. This will be diagonally downwards, and that represents a parabola, which you will get after doing all the work. Now let's look into the word problems. Now we are into applications. I'd like you to read the question, answer. Here is the question. Sam works part-time in a grocery store. The amount he earns is directly proportional to the amount of time he works. He earns $16 per hour. Now clearly, we have written here that the earning is directly proportional to the amount of time. So it is an example of direct variation. Very clear, right? So we can say that the earnings are directly proportional to time worked. Part A is write an equation for Sam's earning. B, find his weekly earning in which he works for 20 hours. C, determine the slope and the vertical intercept for the graph of Sam's earnings. What does each represent? D, for how many hours should Sam work to earn $560? You can pause the video, answer this question, then look into my suggestions. Clearly, the earning can be represented by a straight line. When he doesn't work at all, he will earn zero amount. But the rate is 16 times the time taken. And therefore, we could write the equation as E equals to 16t, where E is earnings. So we are saying earns means E, and time is t. The units for time is hours, units for earning is dollars. And based on that, we say earnings is 16 times the time worked, and that gives you a direct variation. Correct? Okay, so the equation for Sam's earning is E equals to 16t. Now find his work earnings in which he works for 20 hours. Substitute 20 for t. So in that case, the earnings will be 20 times 16, which is $320. Determine the slope and the vertical intercept for the graph of Sam's working. So the slope in this particular case is 16, right? The slope is 16, which represents the rate of change or rate of earning per hour. And the y-intercept is of course 0, which means that if it doesn't work, he doesn't get paid. For how many hours should Sam work to earn $560? Well, divide 560 by 16 to get the time, which comes out to 35 hours, and that is how you're going to solve it. So it's a direct variation case. Now here is the next example. The question here is, Anil works part-time in a grocery store. In the first week, he earns 450 for 25 hours, and in the second week, he earns 648 for 36 hours of work. Anil's working can be modeled by a linear relation. So we have already given that the working is a linear relation, right? So since we know it is a linear relation, it could be direct or partial. So we're given 2 points here. So when we are drawing the graph of this, we'll consider the time along the x-axis and earning along the y-axis, correct? So you can always consider earning here and time there. We're given 2 points in this particular case. One is for 25 hours, the other one is 36 hours. So we know 1 point is 25 hours worked, 450 earned, correct? The other point is 36 hours worked and 648 turned. Now that will be represented by a straight line, correct? Okay, so these are the 2 points which are, let us say, given to us. We need to now find whether it goes through origin or not. Depending on that, it will be partial or direct. But we could do directly also. That is, we can find what is 648 divided by 36 and what is 450 divided by 25. If both are different, then it is partial. If both are same, it is direct. You get the idea. Based on this, I'd like you to pause the video, answer the 4 questions given here. Okay, here is my solution. So as you can see from the given information that the rate 450 divided by 25 and 648 divided by 36 both give you the value of 18. Since the value is constant, we can say that y equals to k times x, right? In this case, k is 18 since that is the rate, right? So we get our equation and we'll define our variable e as the earning, t as the time taken, and we get an equation which is represented here in a graph, straight line going through the origin. Now, to find the other answers, explain the significance of slope and the vertical intercept. Slope here represents the variation, which is rate of earning per hour. And the y-intercept of origin represents that if 0 hours are worked, then 0 is paid. For how many hours should Anil work to earn 756? Divide 756 by 18 to get the time 42 as our answer. Now here is question number 7. Anna works part-time in a grocery store. In the first week, she earns $325 for 20 hours. And in the second week, she earns $565 for 36 hours of work. Anna's working can be modeled by a linear relation. Classify Anna's earnings as a direct or a partial variation. So first part, what you could do is you could divide 325 by 20, get a value, and also 565 by 36, get a value. If both are same, then direct. If they are different, this is partial, correct? You could do that, right? So in this particular case, you may figure out that they are not the same, they are not equal. That means partial. Is that clear to you? That means you have to find slope m, which will be using these 2 points, 325 minus, you could use 565 divided by 20 minus 36. You get this value, which will be m. And then write the equation in the form y equals to mx plus b. You can use any one point, could be 325, 20, correct? And answer the rest of the questions. So you can now pause the video, answer this question, and look into my suggestions. Here is the solution for question number 7. So as I was saying, find the ratio of 325 to 20, 565 to 36. It is not the same, and therefore we can say it is a partial variation. Equation will be of the form y equals to mx plus p. To find m, we'll do y2 minus y1 divided by x2 minus x1. So we took the higher values first. 565 minus 325 divided by 36 minus 20 gives us 15. Therefore, the equation is y equals to 15x plus p. To find the value of p, substituted x as 20, y as 325 using the first condition. Then rearrange and find the value of b as 25, and therefore the equation is y equals to 15x plus 25. The earnings are now written as 15x plus 25. We can now answer the rest of the questions using the equation y equals to 15x plus 25. How much will she earn in 40 hours? Substitute 40, calculate, you get the value 625. For how many hours will she get 670? Substitute 670 for y and then find the solution. You could rearrange the equation, write as in terms of what x is in terms of y, and then do it. So change the subject, right? So here we have used the subject, change the subject, and then answer. So that becomes our other strategy. So I hope the strategy is absolutely clear. Now let's look into the next example. Here the question for you is 8 liters of milk is consumed in a household. After 2 hours, there is 6.4 liters of milk left. Amount of milk left M after any number of days n until it runs out is a partial variation. So we're given that's a partial variation. That is, if you try to graph this, then what you get is something like this, right? Where we are starting with a value which is how many liters of milk? 8 liters of milk, right? So this is milk remaining, and that is the time in days, right? That is the number of days n. Let me write n here, correct? So that is the kind of graph. We are given one value here, which is after 2 days, that means when n is 2, the remaining milk is 6.4 liters, right? This is in liters. You started with 0 and 8. That gives you the slope and the equation of the line, and you can actually answer the rest of the question. I'd like you to pause the video, take this as a test question, answer, and then check with my solution. Here is my solution to the same. So as I was saying, you can actually sketch a rough graph. We don't know what is the x-intercept, but we know what the y-intercept is, since we know it starts with 8 liters. So 8 liters is your y-intercept. We also know two critical points on this, and those two, one is the y-intercept itself, the other one is at 2 days, which is here. We have a point which is 6.4, right? So 2 and 6.4. Using this point, we can find the slope. So let's find the rate now. So the rate here is 6.4 minus 8 divided by 2 minus 0, minus 0.8, right? So it is decreasing each day because it is being consumed. So milk remaining can be written as minus 0.8 n plus 8, since 8 is the y-intercept. Now we can answer the rest of the question. Milk after 4 days means substitute 4 for n and you get 4.8, right? So that will be the answer here. Now, on which day the milk runs out? That means m is 0. For 0, number of days comes out to be 10, so the x-intercept will be 10. And here is the graph for you. So I hope that is absolutely clear, and that is how you're going to solve it. Here is the last question of our series on direct and partial variations and applications. The question here is, Peter enrolls in a fitness program. His total cost is made up of a sign-up fee and a cost per class. The table below shows information about his total cost C in dollars when he attends n classes. So the variable has been defined for us, n and C. The data shown here is number of classes 8, the cost is 60, For 20 classes, the cost is 108. We need to determine the equation for this linear relation, find the cost for 15 classes, and how many classes can Peter attend for $200. You can now pause the video, answer, and then look into my suggestions. Now you're given 2 points that will give you the slope. So the strategy here is find the slope, which in this case will be 108 minus 60 divided by 20 minus 8. Then you write down the equation y equals to mx plus b. You can use any one of these points. For example, you can use 8 and 60 to find the value of b. That will help you to answer. So once you're done, look into the solution. The solution here is simple and straightforward, just as we discussed. First thing, we define a variable Cn. R is the rate at which the classes are being costed. So let's find R. 108 minus 60 divided by 20 minus 8 gives you 4. So $4 per class. So the cost is 4n plus b. To find the value of b, we'll actually use one of the points. I've used the point 8 and 60. Okay. So here we did a calculation mistake. For 8 classes, the charges were 60, right? So let's redo it. So we have C equals to 4n plus b. So when n is equal to 8, the cost is 60. So we'll use 60 equals to 4 times 8 plus b, which is 60 equals to 32 plus b. And therefore, 60 minus 32 is b. 60 minus 32 is equal to what? So when you take away from 10, you get 8, and 5 minus 3 is 2. So it is 28 per class, correct? So 28 per class, and therefore the equation will be cost C is equal to 4 times n plus 28, right? So this value is not 4. This should have been, so we'll just cross this out, correct? So we get our equation, which is C is equal to 4n plus 28, not 44, right? So in this case, the fixed cost of B is 28, right? And now we'll calculate, find the other answers using the new equation, which is the correct equation. Perfect. So find the cost for 15 classes. We're going to substitute 15 here. So C equals to 4 into 15 plus 28. So let's calculate. 4 into 15 is 60, right? And then to this, we'll add 28, and that gives you $88. So for 15 classes, it will be $88. How many classes can Peter attend for $200? So write 200 for C, right? And we have 4 times n plus 28. So 200 minus 28 divided by 4 gives you the value of n. So 200 minus 28 and divide by 4 gives us 43 classes. So we have 43 classes which could be attended for the given rate, right? So I hope that makes sense. Take care of the corrections, right? These are the corrections. And I hope you get the same answer. With that, we come to an end of this particular video. I hope you've learned how do we solve different questions based on direct and partial variation. So that will give you a good foundation for direct and partial variation understanding and examples based on it. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.